NCM Learning Center.
Good morning friends. In the part 4 AC circuit analysis concepts, we are going to discuss about the real power, reactive power and apparent power calculations by solving the problem. After understanding the concepts, definitely you can solve any type of questions from these concepts. Okay, let me discuss. Before solving this problem, you should know the basic points. The first point is, what is active power? The active power P is equal to Vrms Irms cos pi for single phase system. The other name for the active powers are true power, real power and actual power. The third point, what is reactive power? Reactive power Q is equal to Vrms Irms sin pi. So fourth one, the complex power S is equal to sum of active and reactive power S equal to P plus JQ. So substitute here, we will get S equal to Vrms Irms cos phi plus J into Vrms Irms sin phi. This is in rectangle form. If you convert it in polar form, S equal, you will get the magnitude is equal to Vrms Irms. Angle theta or pi is the angle difference between the Vrms and Irms. Fifth point is apparent power. The apparent power is the magnitude of complex power. So, modulus of S, that means magnitude of S is equal to root of P square plus Q square is equal to Vrms into Irms. Okay, next point, what is power factor? The power factor is the angle difference between voltage and current. For example, if the voltage V is equal to Vm sin omega t plus pi 1, that means the voltage phase angle is pi 1 and current I is equal to Im sin omega t plus pi 2, the phase angle of current is pi 2, then the power factor will be cos of angle between the voltage and current, pi 1 minus pi 2. Okay. Then leading power factor. In an AC system, if current leads the voltage, then the power factor will be leading power factor. If current leads, the phase angle difference between the voltage and current will be negative because current leads. But the angle difference between the voltage and current will be negative one. So, for leading power factor, the phase angle difference between the voltage and current will be negative. Then lagging power factor. In an AC system, if current lags the voltage, then power factor will be lagging power factor. Current lags. So, the phase angle difference between the voltage and current will be positive. So, pi is equal to positive for lagging power factor, pi is equal to negative for leading power factor. You should know these points. Then only you can solve the problems. So, now we will solve the problem. Let me solve this problem. This question is asked in Gate 14 EC department. The question says, two loads are connected in parallel with a source of 230 volt RMS. The first load draws 10 kilowatt at 0.8 leading power factor. The second one draws 10 kVA at 0.8 lagging power factor. Then the complex power delivered by the source is what? So, from the observation, we can draw circuits. Here, two loads are connected in parallel. Okay. 230 volt RMS is connected parallel with the loads. So, okay. Load 1 draws 10 kilowatt at 0.8 leading power factor. Load 2 draws 10 kVA at 0.8 lagging power factor. But our objective is to find the complex power delivered by the source. Okay. We know that what is complex power? The complex power S is equal to Vrms into Irms. This is the magnitude of the complex power. Okay. The magnitude of complex power is the apparent power. If we find the magnitude of the complex power, we can find. Here, Vrms value is given 230 volt, but we need Irms. So, we take this current, load 1 draws Irms 1 and the load 2 draws Irms 2. The summation of current is the source current Irms. So, for calculating the Irms, we need Irms 1 and Irms 2. So, first we find the Irms 1. For load 1, 0.8 leading power factor is given. So, power factor cos pi is equal to 0.8 leading. From that we can find the pi 1 value. Pi 1 is equal to cos inverse of 0.8. We will get answer is 36.87. Why it is negative? Here it is a leading power factor. Leading power factor means the phase angle difference between the voltage and current will be negative because current leads, voltage lag. So the phase angle difference between the voltage and the current will be a negative one. So pi is equal to minus 36.87. Then here kilowatt is given. Kilowatt means real power, active power. The unit of active or real power is kilowatt. So P, VRMS IRMS cos pi is equal to 10 kilowatt. So kilo means 10 power 3. So 10 into 10 power 3 watts. From that we can find IRMS 1. IRMS is known, power factor is known. We can find IRMS 1. So IRMS is equal to 10,000 divided by VRMS value 230, power factor value 0.8. So the magnitude is 54.348. But the angle difference between this IRMS 1 and VRMS 1 is equal to 36.87. So minus 36.87. Okay, good. For load 2, power factor is given cos pi 2 is equal to 0.8 lag means current lag. So the phase angle difference between the voltage and current will be positive. So plus. So kVA is given 10 kVA. kVA means VRMS IRMS 2. Okay, 10 input and 10 over 3 VA. Here VRMS value is already known 230. So from there we can find IRMS 2. So IRMS 2 is equal to 10,230, 43.478. This is the magnitude. But the angle is 36.87. Now find IRMS value. IRMS is equal to IRMS 1 plus IRMS 2 with including phase angle. If we have to find the magnitude, then IRMS is equal to root of IRMS 1 square plus IRMS 2 square. If we have to find magnitude only, but here with including the phase angle. So substitute here, we will get IRMS 1 value and IRMS 2 value. Both are in polar form. For addition, we go to convert the polar form into rectangle form. Then only we can add. If you don't know the conversion of polar into rectangle and rectangle into polar, just refer the part 1 video. That video link is attached in the description of the video. Just refer it. If you refer, you can easily know the conversion of polar to rectangle and rectangle to polar. Okay. Now we will get the IRMS value. After converting the polar into rectangle, we can get these values. Now add this value. IRMS equal to 78.2608 minus J 6.5. This is the IRMS value. But the complex power S equal to VRMS and IRMS with including the phase. So VRMS value 230, IRMS value this value. Multiply this value, we will get 18 kVA minus J 1.5 kVA. So option B is correct. If you need to calculate the apparent power, just find the magnitude of S. Visit our website www.ncmlearningcenter.com. You can get the video materials for GATE, IES, ISRO and other competitive examinations. Then PDF materials, PDF book materials prepared for NCM Learning Center. If you use this material, definitely you can get the good marks in the competitive examinations. Then you can get the test series. Join our WhatsApp group, NCM Learning Center WhatsApp group. That link is attached in the description box of the video. Join in our group. If you have any doubts related to the discussion, just post in the WhatsApp group. You can get the solutions. Okay, good. Thank you.
Thanks for watching. Click the subscribe button and hit the bell icon for notification. Like, comment and share.